All right, you guys, so for this second one, we have that we need to consider the function f of x equals 3x minus 1 plus 4x to the power of negative 2. Okay? Part of the graph of y equals f of x, which is basically just, our graph, right, is shown below. And so it has this part where it goes all the way up. Then there's a little bit of space in between. There's something going on here, right? There's a little bit of space in between. Then it sort of like comes back with a curve. There's something here, and that is my graph. See? All right, cool. So the function is defined for all values of x except for x equals a, and to write down the value of a. All right, so intuitively, what I just told you that over here, right, it sort of like disappears. Well, that would be where the function is indefined, right? Because it tells us that the function is defined for all values of x, so all these values of x are legal, except for when x equals a, which is somewhere around here. See? We're not sure where, but it's somewhere around there. When a function is indefined, that means that the value of x that you're putting in is not legal. Okay? When something is indefined, you're putting in a value of x that is not legal. It breaks some math rule, and it can be a lot of different things. Okay, so let's go piece by piece. Let's write down f of x. F of x equals 3x minus 1 plus 4x to the power of negative 2. And so apparently this function is undefined at some point. When x equals a, it is undefined. See? So when x equals a, we have something that is undefined. Now, let's look at the nature of this function and see where my values might get undefined. And so piece by piece, I'm going to prefer, and this is a personal thing, to put the negative 2 in front. See, so I'd rather have, just reorganizing a little bit, f of x equals 4x to the power of negative 2 plus 3x minus 1. Okay, so that way I have the 2 in front. And what does the negative exponent do? What does the negative exponent do? What it does intuitively is that you are technically going to flip it. And so a negative exponent means that you flip it. So never ever forget that. You flip it with a negative exponent, okay? And so what do I flip exactly? Well, this negative exponent is affecting what? Is it affecting the 4? Is it affecting the x? Is it affecting this 3? Ladies and gentlemen, it is only affecting this x right there. That means that if I apply the negative exponent, what do? I flip it. Okay. So do a backflip. 4 divided by x to the power of 2. So you flip it, and then it goes positive? No, 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 no. You flip it, and you multiply by negative 1. You flip it, and you multiply by negative 1. You flip it, you multiply by negative 1. Let's leave that super duper clear. So if you have x to the power of negative 2, you flip it, so it ends up on the bottom, right? And you multiply the top, the negative 2, times that negative 1, right? And that means you end up with 1 divided by x squared. Why is it useful to understand it this way? Because the day of tomorrow, you might have something that looks like this. 1 divided by x to the power of negative 3. So if you want to flip it, well, now it's going to go on top. And you need to do the negative exponent thing. Multiply by negative 1, so you don't forget. It goes positive. And so very intuitively, you can kind of think that like flip and change symbol. Ooga booga. Flip, change symbol. All right. That means if you have x squared, which is something that you would probably want, but just so that we're on the same page, if you have x squared, you can flip it and multiply it by a negative 1. So you can actually rewrite x squared as 1 divided by x to the power of negative 2. All right. That is all you need to know for negative exponents. See? Yeah, whatever. So this negative exponent makes this happen. So now I have 4 divided by x squared plus 3x minus 1. All right, and so now we need to see what makes this function be undefined. And so whenever they're asking for an asymptote, which is something that shows up later, see? You gotta think about what undefines my function, okay? Or when they're talking about domain and range, think about what limits my function, which is sort of like what undefines it as well, okay? So, I used a lot of buzzwords right now, and I'm sure at least one of you is thinking, what the fuck? I know I've heard of asymptote, but I forgot what it was. What is domain? What is range? Which one was X? Which one was Y? Alright, guys. Domain and range are the values that X can take in domain and the values that Y can take in range. Literally X and Y, okay? And so domain are the values that X can take. Range are the values that Y can take. This can be limited by stuff that your function has, okay? An asymptote is something that is never touched. So for example, if I have, let's say, something that looks like this, okay? Just whatever, I don't know. And we can do something like this, okay? So if I have a function that looks like this, and over here we have, I don't know, 1, ¿cierto? That is a 1. Then I can say I have a horizontal asymptote. Horizontal asymptote at y equals 1. See, because at y equals 1, x is never going to touch that value. See, you can also say you have a vertical asymptote, maybe at x equals 0, because your value of x will never touch right here. See, x equals 0, y equals 1. So that is the intuition of asymptotes. That is just a quick, like 101, see? And so when you look at this function, well, what is special about this function? Of course, what's special about this function is the negative exponent. What did the negative exponent do? It made my x be on the bottom. It made it be on the bottom in what is called the denominator, see? And so you have numerator on top, you have denominator on the bottom. When you have an x on the bottom, you have to be careful because x cannot equal 0. Why can x not equal 0? Because you cannot divide by 0. Ladies and gentlemen, 0 divided by 3 is how much? 0. 3 divided by 0 is how much? It's undefined. Quite literally, it is undefined. And if you're not sure or you don't remember and you're in the middle of the test and you're like, fuck, there's an x in my denominator, but I don't recall if it was dividing by 0 on the bottom or on top. Just put in your calculator. Who gives a shit? So 0 divided by 3 gives you 0. 3 divided by 0 gives you error. Divide by 0. Undefined. You cannot divide by 0, guys. Okay, it is that simple. So here, I identify that x cannot equal 0. And what value of x made it undefined? Well, we just found out that x equals 0 makes it undefined. So, that was a little bit of a long introduction to this exercise, but I think that's fine. A equals 0 because x cannot equal 0. See, you can understand it this way if you'd like. X cannot equal 0, so what undefines it? A equaling 0. See? It's the same idea. Alright, so that is part A. Part B, we need to use your graphic display calculator to find the coordinates of the local minimum. And so there's two very important buzzwords here. On the one hand, you have local. On the other hand, you have minimum. And so what is going on there? See, imagine we have a function that looks a little bit like this. You have something that goes, I don't know, whatever. Just, oops. Let me try that again. So you have something that goes a little bit like this. See? And let's say that here your function dies. Like, this is where it starts, this is where it ends, period. Okay? Here you have x, here you have y. And so, guys, take a moment and look and point out for me, please point out for me the maximums. And so you take a moment, you look, and you say, okay, so I have a maximum here, you have a maximum here, here, here. And so all the maximums are in orange, okay? Now, maximums can be defined, maximums and minimums can be defined in two ways. You have what they call the local, which is what shows up in this exercise, and you have the global. And so following that intuition, I think it's easier if we start with the idea of the global. So the global maximum is going to be the biggest maximum. And so what is the biggest maximum? The biggest maximum is going to be this guy here. And so if this is my global, then which ones are my local? Let's use this color here. So for local, we're going to have that this is local, this is local, this is local, this is local. So basically, all you really need to keep in mind is that the global is going to be the biggest maximum, or if we're talking about minimum, the smallest minimum, okay? And the local is just going to be all the other ones, okay? And so here I would actually have 1, 2, 3, 4, 5. So this is 5 minimums, where I have 4 local minimums and 1 global min, okay? So that is intuition for local and global. This is for maximums. If I do the same exercise for, points out for me the minimums, it's going to be quite similar. We're going to have, whatever, let's just use this color here. So we're going to have that for minimums, we have this minimum, this minimum, this minimum, this minimum, this minimum. See? 1, 2, 3, 4, 5. Which one is the global minimum? It's this one. So this is going to be my global minimum. And my local minimums are going to be all the other ones. See? And so here, 1, 2, 3, 4, 5. I have 5 minimums, 1 global minimum, and 4 local minimums. Okay? Whatever. That's the idea of global and local. And so why do they ask for us for the local minimum? Because technically, this graph keeps on going. Okay? In both directions. And so the minimum is going to be your smallest value. And so yes, we're used to the minimum being like, I don't know, like right there. See? Why? Because we're talking about a quadratic that looks like this. Anytime there's a curve or a point of change, your minimum is going to be here or your maximum is going to be there. Okay, this is not new news for most of you probably. This is going to be the vertex, see? And your quadratic. And it's usually the vertex has the minimum or the maximum. See, on the left example we have a maximum, on the right example we have a minimum. See, and so for when they ask for a local minimum, it's like the one you see in this picture. Okay, because you might have a minimum over here that goes like that, but you don't see it. And so what's the local minimum? What's the minimum that they're seeing? It's the one that I have highlighted in yellow in my graph right now. Just to leave that idea very clear, what we see in this graph right now is something that goes along the lines of this and this. And so you know that there's a minimum there for sure, see? And so you can call this a local min. Now you don't know if this local min is the global min or it's just a local min, because this graph might keep going and it might keep going like this, see? And so this minimum would actually be like the global one, like the smaller one. All right, whatever. Enough blah blah. Point is, there's more than one minimum. You know that this is a local minimum because it's one that you're seeing. Okay? Fuck it. Here's a local minimum. How the hell do you find it? Because we can use our graphing calculator, what you do is you go ahead and graph and then use functions in your graph to find the minimum. Okay? There are other ways to do it, but I'm going to show you this way because it's a little more direct. Okay? It might take more time, but it's more reliable. And I'd rather show you the reliable way. So you open up your graphing calculator, you go to y equals. Okay, so the point of y equals is that you can plug in functions and then play around with them. So I'm going to put 3x minus 1 plus 4x to the power of negative 2. All right, double check that it's all okay. Go ahead and graph. And so probably you are right now graphing and you're having the same issue as me. Nothing shows up. Nothing shows up, not because you put in your stuff wrong, but because the window is wrong. Okay, maybe you're too zoomed out, maybe you're too zoomed in, maybe you're looking at the wrong area. So what you can do is, what I suggest actually is first start by pressing zoom, go all the way down to what is called zoom fit. Sometimes zoom fit helps you find like the points of like the important points, like intersect, min, max, whatever. And so here I did assume fit, and as you can see, I can see a little bit more of the nature of the graph, but the dimensions are still a little bit fucked up. And so what you can do is go into window and start playing around until it looks nice. For example, this Y max of 350 is probably making it look like shit. Now, a quick tip, see? If you're not sure what values to put here, well, sometimes they give you values. So I'm going to put a minimum of x equals -4, a maximum of x equals 6, a minimum of x equals -8, that means y equals -8, and a maximum of y equals, this is probably, yeah, this is 14, so y equals 14. And so there, just like that, whoops, I can go back here and put, okay, minimum -4, maximum 6, y min is going to be -8, and this one's going to be 14. All right, and just a nerd sort of moment, but the SCL, okay, so see how you have X SCL and Y SCL? That is by how much it sort of changes. What I mean by this, if you go ahead and graph now, see how each of these have like those little sticks going around, like this part of the graph? So those sticks, okay, the X SCL shows you how much distance is between each of these. And so if right now my x equals 1 for SCL, x SCL equals 1, that means from here to here it's 1. From here to here it's 2. I mean, sorry. Each of these is 1 point of distance. That's what I mean. If you change your x SCL to, I don't know, 2, that means each of these jumps is going to be a distance of 2. As you can see, all that really helps with is sometimes making your graph look nice. Okay, it doesn't aid you in finding the intersect quicker or whatever. No one gives a fuck. Okay, as long as you can see it, that's all that matters. I just thought I'd share that so that you know what it is. Okay, don't ever change it, just leave it on 1. So now I have my graph, and now I need to use my graphing calculator to find the minimum. So because we are trying to calculate something, we can go ahead and press the calculate button that is on top of trace. So you press second, trace, you hit calculate. So here you have a lot of fucking tools. You can find some random value, you can find zeros, minimum, maximum, intersect, etc. See? Obviously, we're trying to find the minimum. So we press minimum, what does it ask for? It asks for left bound. Later on, it asks for right bound. And so if I go ahead and put, I don't know, left bound here, and right bound there. What I'm basically doing, just so that we understand, okay, what I'm basically doing is that if I put, say, if I put the left bound here, so left bound, and I put the right bound here, well, then the last part is guess, which is basically like pick your minimum. So I'm going to pick here. What this does is that your calculator goes ahead and scans this area from the left bound to the right bound. It sees which minimums it finds, and it uses what you guessed for to pick that minimum. Why is that important? Because let's say over here you do, I don't know, this is your left bound, okay, and this is your right bound, and I say, nice, scan for minimums. It's going to scan all of this, and how many minimums is it going to find? It's, whoops, I don't know what's happening. Okay. It's going to find 2 minimums, right? It's going to find this one and this one. Well, maybe this one, see? And so this is where your guess function comes in and helps you pick one or the other, okay? That is why it asks for left bound, right bound. It's just helping you tell your calculator where to scan. And the guess thing is for you to pick a minimum if there's more than one. In this case, we can guess fucking anywhere because it only picks up on one. Okay, well, apparently I need to guess within the bound. Big fucking deal. So left bound over here. Right bound over here. And I just guess anywhere within the bound, apparently. It's going to find the one I need because it's scanning in the right area. That is my minimum, see? And so the local minimum we're going to write is following this. Give me one moment. Yeah, so we can put 1.38672 and 5.24025. Then suddenly for this next part, they tell us that the equation f of x equals w, where x is part of all real numbers, has three solutions. Identify one possible value for w. All right, so this part is definitely pretty weird, and you need to understand some conceptual stuff, I guess, in order to solve this. See? And so let's go piece by piece. See? First of all, you might be reading that and thinking, what the hell, I don't get it. Okay, and that's where I tell you, guys, a lot of times in the IB, and I'd say especially for paper 2 actually, I'm going to go on a limb here and say especially for paper 2, usually like what you need for part C is something you did in part B. What you need for part B is something you did in part A. Why is this useful to know? Because it can be a massive hint for how you answer the next part, okay? Um, it's not always the case, but consider it because it can be a massive hint. So, the equation of f of x equals w, okay? So that means I equal this to like a w, and I can have three solutions. Okay, so f of x equals w. Let's understand something right off the bat, see? So f of x equals w. Actually, well, let me start in a different way. So let's say you have f of x equals, I don't know, 3x plus 2. See? Just a random ass function. I'm just trying to explain the following idea. F of x is a very fancy way to say what? F of x is the fanciest way you will ever meet of saying y. So f of x equals 3x plus 2 is the same as if I told you y equals 3x plus 2. Alright, so why do mathematicians use f of x? Because then you can keep good track of what you're plugging in for x. For example, f of 2, f of 2 is basically you asking your function, what is y when x equals 2? And that is why f of 2, what you do is that you plug in this 2 into this x, and you end up with 3 to the times 2 plus 2. In other words, 6 plus 2, in other words, 8. So f of 2 equals 8. See? All right, so that is sort of the intuition of what is f of x. See, f of x is basically just y. And so what's going on here, they're telling me that when f of x is w, so basically for some value of y, where it is part of all real numbers, okay, this is just a fancy way to say it's part of all real numbers, which is like all numbers really, okay. So for some value of y, this equation has three solutions. Okay, now it's a little bit more friendly. For some value for y. Okay. Let's say I have a y of 2. A y of 2, all right? A y equals 2 is where? It's right here. So a y of 2 goes like this. How many solutions does y equals 2 have? All right, I know that some of you are like, brother, what the heck are you doing? If y equals 2 and you draw this horizontal line because we're talking about y equals 2, ¿cierto? Where does it touch my function? Ah, it touches my function here. So how many solutions does it have? It has one solution. Why is this important to know? Because let's say you are solving a parabola, ¿cierto? Something that looks a little bit like this. And they ask you to find the famous zeros. Okay, the famous zeros are wherever your function touches at x equals 0. Which in other words is the same as finding your x-intercepts, okay? So what you're technically doing is that much how we just did y equals 2 and found two solutions, right? When you find zeros, you are drawing a line through y equals 0 and seeing where you cut x. All right, so small mistake here. I did not mean x equals 0. I rechecked myself. For the x-intercept, you find y equals 0. For the y-intercept, you find x equals 0. Sorry about that. Small detail, but whatever. Point is, this thing of like drawing a line and finding the solutions, you've been doing it all along. You know, you've been doing it for the quadratic function. That is actually why you equal your function to 0 when finding, I don't know, the zeros of x squared plus 2x plus 1. You equal it to 0 because it forces you to do this two solutions thing by drawing a line. Okay? All right, cool. Why is that useful? Because if I go back over here, so at y equals 2, I have one solution because it touches only once. Okay, so where does it touch 3 times? Where do I have 3 solutions? Where does it touch 3 times? At y equals 4, it still touches only once. At y equals 5, it still touches only once. At my minimum, ooh la la, at my minimum, it touches here and here. So here it touches 2 times at my minimum. And the moment I go a little bit above my minimum, just a little bit, right above, for example, there, it touches how many times, ladies and gentlemen? Bada bim, bada boom, it touches 3 times. And so anything above your minimum is going to have 3 solutions. All right? So one possible value for W, well, you can just, I don't know, you can put like y equals 12 and it's going to work. See? I mean, sorry, W equals 12. It's going to work. It's going to give you those 3. See? If you're not very convinced that that's going to get you a point, you can be very rigorous and just put like any value greater than my minimum, and then make sure you put greater than and put the value of your minimum to show your work, 5.24025. So that would be for part C. And notice how for part C we needed something from part B. So the minimum was relevant because that 5.24025 came from part B. See? All right, let's keep going. They tell us that the line y equals mx minus 1 over 4 is tangent, keyword, tangent to f of x when x equals negative 4. Write down whether the value of m is positive or negative. Justify your answer. So here we need to clarify a little bit. What is even a tangent? Okay, once we have that keyword ingrained in our brains, the intuition and everything, finding it, the answer to this next question is actually very easy. And so a tangent, you guys, make memory, is something that touches your line once and then never again. For example, let's say I draw a quadratic again that looks something like this. Let's say that I have a tangent at, I don't know, x equals 2. And so at x equals 2, which is around here, I have a tangent. That means it's a line that touches once at x equals 2. At x equals 2, it touches once and then never again. So this would be a tangent at x equals 2. Why is this relevant? Because sometimes it can help you find certain slopes or whatever. For example, if you force this tangent to have a slope of 0, if your tangent has a slope of 0, what this can actually help you do is find what we call the minimum. Why does it work that way? Because the slope of this guy here is, I don't know, it's positive, right? It's like 3, it's going up. The positive of this guy here is, I don't know, negative 4, whatever, I don't know, see? But as you get nearer and nearer the minimum, the slope actually grows. And so here's the slope of negative 4, here's the slope of negative 3, here's a slope of, I don't know, negative 2, and eventually you're going to find a slope of 0. A slope of 0 is a horizontal line. Completely horizontal line. Here you have a slope of 0. And so if you make a slope of 0, it can help you find the minimum point, the vertex. See? All right, that was like a nerd moment, but just so you know, usually when you find the derivative, which helps you find slope, you just equal it to 0. Why? Because it helps you find a minimum or maximum. Okay, cool. So that we have a tangent when x equals negative 4. So first things first, let's not complicate ourselves. Where the hell is x equals negative 4? X equals negative 4 is here. So then it goes all the way down. See? So probably it's probably something that is just going up. See? So there's not much we have to be scared about. You can probably just put, looking at the graph, it has to be positive. See? Now I know that some of you are not very comfortable with that, but I am going to tell you right away that if you look at the answer key, that is literally a way to answer. You can say, the function is increasing at x equals negative 4, so the slope has to be positive. See? And so you can conclude that just by looking at it. I mean, literally, you can conclude that by looking at it. It's what's likely, whatever. See? Now, let's get a little bit more scientific because it's not the idea to do things eyeballing it. See? So at x equals negative 4, is it growing or not? Let's find a way to sort of prove it. See? So if I have my function here and my y equals, let's see what value of y I get for x equals negative 4. So what I can do is I can go to table. So press second and then graph to hit table. So when x is 4, y is 11. Now notice, what's the relationship? So, well, eventually when you reach 0, you get the error undefined, right? But as you can see from 1 and above, so 1 is around 6, 2 is around 6, on 3 it starts growing, on 4 it starts growing, on 5 it starts growing, 6 it's growing, 7 is growing. So there it's definitely growing, see? It's not some sort of point where like it grows then stops growing or shit like that. No, it's growing, it's increasing. And so what we can say is that because it's increasing, then your tangent has a positive slope. What is m in this context? It is slope. Okay, so y equals mx plus b. What's the intuition? This is your y-intercept. This is your slope. And so when x equals negative 4, it is definitely going to be growing somewhere down here, ¿cierto? But it's going to be growing. It needs to have a positive slope. See? So m has to be positive. Justification of my answer, function is increasing. Function is increasing at x equals negative 4. See? And how did you prove it or find out? By looking at the table. See? So yes, we eyeballed it a little bit intuitively, but then we checked with the table and it is correct. So function is increasing at x equals negative 4. This is one point. The other point comes by saying that the slope has to be positive. See? All right, cool. So now we also learned a little bit what tangent is. So that's nice. All right. Then they give us that a second function, ooh la la, is given by g of x equals k times p to the power of x minus 9, where p is greater than 0. The graph of y equals g of x intersects the y-axis at the point this and passes through the point this. With all of that, we need to find the value of k and p. Guys, I'm going to say right away, like this right here could totally be like a question for paper 1, okay? So this right here doesn't have much to do with parts A, B, C, and D. Well, the last part does, okay, like part H and G. But this by itself is like its own exercise, okay? Why am I pointing this out? Because the day of the exam, you might not know how to do A, B, and C, and D, but you will know how to do E, see? I know that I said earlier that part B has to do something with part A and etc., but it's not always the case, okay? And I know that's a weird tip or trick because I'm not telling you that it's always the case, so it's not a rule of thumb you can use, but it is something you can consider. If you look at an exercise and the first 3 parts, you're like, fuck, I have no idea, get points where you can. Look at part E, look at part F, look at the last question. Maybe there's something you can do, okay? Get points where you can, don't give up. That's my message. So, what is the value of K? What is the value of P? So, we gotta go piece by piece. The key information that they give you, okay, is the value of A, which is a point, and a value of B, which is another point. So let me explain this very, very intuitively. Let me go ahead and zoom in a lot. So I told you guys that g of x or f of x is the same as y. So let me rewrite this and say that y equals kp to the power of x minus 9. Now, which variables do I have here? How many? I have one variable, I have another variable, I have a third variable, and I have a fourth variable. And so right now, it's very hard to solve this because there is more than one variable. Okay, that is the idea that I'm trying to share. The moment you have more than one variable, it's hella hard to solve. See? So let me go back, write this again. So right now I have four variables, and it's hard to get one of them alone. See? It's hard for me to end up with, I don't know, y equals 2, because there's four fucking variables. It's gonna end up as y equals 2 plus k times p, and like x is somewhere. See? So point is, there's a lot of fucking variables. You need to find a way to get rid of some of them. And so this is why they give you points. For example, if I go ahead and plug in this point A, and I know I can plug it in because they tell me that the y-axis is at point A, so it's part of the function. See, I'm not plugging anything in. I'm plugging in a specific value that is in my function, so it is legal. It's going to work. If I go ahead and plug that in, well, my x is going to be 0, my y is going to be negative 5. So negative 5 equals k times p to the power of 0 minus 9. Now, something to the power of 0 equals what? Anything to the power of 0 equals 1. And so negative 5 equals k times 1 minus 9. Negative 5 equals k minus 9. Ladies and gentlemen, I just passed from 4 variables to 1, which is amazing, because now I can solve for k, and I end up with, well, plus 9, k has to equal 4. So notice how the intuition is, okay, you have a lot of variables, how you can get rid of some of them. Usually just by plugging in some points, it is something that you can figure out. So now I have k equals 4, which means that in my original exercise, I now pass from having 4 variables to having 3 variables. So now I'm a lot more happy, see? What does that mean when I plug in this point here? This 3 variables is going to go to minus 2 variables. I end up with just 1 variable, which is what we want. All right. Just wanted to mention that so you understand the way of thinking, the intuition, the etc. See? So k equals 4. That is going to be this part here. So k equals 4. All right. I know some of you are probably still thinking or a little stuck on why the hell, whoops, why the hell something to the power of 0, okay, is equal to 1. So just a quick sort of like demonstration, see? The study of math is often considered the study of patterns. See, it's filled with patterns all over the place. And so if you go ahead and I ask you, yo, what is 2 to the power of 3? You're going to tell me 8. Now, how do you know that it's 8? You know that it's 8 because it's 2 times 2 times 2. So 2 times 2 gives you 4, times 2 gives you 8. See? 2 to the power of 2 is what? 2 to the power of 2 is awfully similar. It is just 2 times 2. It is 4. And 2 to the power of 1 is just 2. It's just 2. And 2 to the power of 0, well, this guy online says it has to be 1. So 2 to the power of 0 equals 1. All right. There's there's like 2 ways you can think of this, okay? The first way is that technically all of these different scenarios that I just put in front of you have a times 1. Why is it useful to think about it this way? Because then this 1 tells you how many 2's show up. So, oh, if 1, 2 shows up, then 2 times 1 gives you 2. If 2 2's shows up, then 2 times 2 times 1 gives you 4. If 3 2's show up, it's 2 times 2 times 2 times 1 gives you that 8. And if you work backwards, you see that, okay, so 2 to the power of 0 means I have 0 2's. I have just 1 1 equals 1. That is one way you can think of it. The cooler way, in my opinion, is that to go from here to here, you do what? You do times 2. To do from here to here, you do what? You do times 2. To go from here to here, you do what? Times 2. This is also useful if I go ahead and ask for 2 to the power of 4. Well, you just do this times 2. It's going to give you 16. Ah, okay. So, why is this useful to know? What if I ask you to go backwards from 16 to 8? What do? Well, what's the opposite of multiply? Divide. So 16 divided by 2 gives you 8. 8 divided by 2 gives you 4. 4 divided by 2 gives you 2. And 2, ladies and gentlemen, divided by 2 gives you 1. And so no matter if you do this with 3 squared, no matter if you do this with, I don't know, the world of 3 squared, cierto? So it's going to be from 9 to 3 to 1. Here you divide by 3, see? And so notice how eventually, divide by 3. Eventually, you're going to end up with the number you're analyzing divided by itself. And so the number you're analyzing divided by itself will always give you 1. The number you're analyzing divided by itself is always going to give you 1. See? And so that is why that pattern happens. That is why it works that way. That is just a small explanation so that maybe you remember a little bit more why anything to the power of 0 is going to give you 1. Alright, fuck it. That is the value of k. See? So k equals 4, and now back to the game plan. Right now I have 3 variables. I want to have just 1. So if I plug in the point b, well, x is going to be 3, y is going to be 4.5. So 4.5 equals 4 times p, which we said was, whoa, times p, which we still don't find, to the power of 3 minus 9. And so if I get these values alone, I can do plus 9 plus 9. We end up with 4p to the power of 3 equals, well, 4.5, 4.5 plus 9, 13.5. I can keep getting p alone by dividing by 4. So that means that p cubed equals 13.5 divided by 4, 3.375. And so from here, in order to get rid of this square root, I can do this square root with a 3 hidden in there. Y with the 3 hidden in there because this goes away with this. And so p equals the square root with a little 3 in front of this. How do you put the little 3 in front in your calculator? Well, there's a lot in the math button. So you go ahead and press math. There's a lot of shit over here. And it's going to be number 4. So number 4 gives you what we're looking for. If you ever end up with a bigger sort of number you have to do, you can go ahead and put, let me try again. You can put this 5th option, and you can change, whatever, you can change here, see? You can make this 5, you can make this 7, etc. Just so that you guys know, technically, the default, for example, you have, I don't know, x squared equals 4, see? So you want to get x alone, you do square root, x equals square root of 4. Notice how there's no little number here. Well, there actually is. There's always a little 2, okay? The special scenarios is when that little 2 changes to something else. Why is there a little 2? What is the intuition of this? This little 2, what is it is asking you is one number multiplied by itself twice gives you 4. Which is why, for example, x to the power of 3 equals, I don't know, give me a moment, 8. If I do this square root here, and I gotta put it 3 to get rid of this with this, see? What I'm asking it now is what value multiplied by itself 3 times gives me 8, which as we know is going to be 2, because 2 times 2 times 2 gives me 8. Whatever, guys, it's just intuition that this little number, okay, is how many times you multiply it by itself, see? And so the default, which is why you don't write it, is 2. So here it's not the default, it's 3. So, did I do it already? I did not. So math, put this 3, get 3.375. There is my value of P. So P is going to equal 1.5. All right, we did a lot of sort of review there, but I think for some of you it helps out a lot. So there it is. All right, let's keep going. For part F, what is the buzzword? Da, 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 da. Write down the equation of the horizontal asymptote of y equals g of x. What the hell did I just read? So, blah, blah, blah. Yeah, horizontal asymptote. Guys, I told you earlier that an asymptote is a number that, or a value that your function can never take. Let me write that again. A value that your function can never take. See, for the asymptote. The thing is, you can have horizontal asymptotes or vertical asymptotes. See, usually for the vertical one, you can just find. Ah, fuck. I can't. Here's the thing. So, if you have a vertical asymptote like the one we just saw, which was at, I don't know, like x equals 0. See, so that means for vertical, you have an x value that it cannot be. See, for horizontal, it's a y value that it cannot be. Okay? And so usually for the vertical, see, for the x value, you can just look at what undefines it and then you can figure it out. See? For the horizontal, it's not so easy. It's not so direct of just finding like, oh, where you divide by 0 or where your function doesn't make sense because it gets undefined. It's not as direct, see? And so usually what you need to do is graph it, okay? Or at least that's what I suggest. It's the easiest way, in my opinion. All right, whatever. And so basically, there is an equation of the horizontal asymptote of this equation, g of x. Now, g of x, what is it? Well, I already found k, I already found p. G of x, in a more fancy way, is going to be 4 times 1.5 to the power of x minus 9. So if I go ahead and graph that in my graphing calculator, we end up with 4 times 1.5 to the power of x. Sorry. And then I can graph it. So here, most of it shows up, but I don't really see the asymptote. So I can go ahead and do zoom fit to try to see if my window nails it more quickly. Here I get a bigger sort of function. All right, so now I'm starting to get the idea of where the asymptote might be. And so I have some sort of function that looks a little bit like this, see? And so there has to be a horizontal asymptote right here. The thing is, right now I don't see it, right? So what I can do is I can zoom out a shit ton. So you can either press zoom, zoom out, or you can just change the window, see? I'm just going to change the window, like, to each their own, see? So negative, I'm just going to be very exaggerated so I can see the answer right away. So negative 400, we're going to leave the same x max. Or actually, 50, just so that it looks a little bit more pretty. Okay, clearly I zoomed out too much. Gotta take a chill pill sometimes. Let's put negative 40, max 15, and a bigger y minimum. So y, I don't know, negative 25. Yeah, graph. Okay, now it's very apparent where my horizontal asymptote is. See, so clearly that is the value that I cannot take. Now, how do you find it? Well, that's the thing. Use your graphing calculator. What I suggest is go, actually you can go trace. So this trace button, what it does is that you can move along your function and it gives you each and every value of each point. So for example, right there, x is negative 10, y is negative 8.9. See? So if I go a little bit more to the right, this point here is 3.88 for x and 10 for y. See, it makes sense because positive y, positive x, There it is. See? So how can this help you find the asymptote? Well, go to the part where your values sort of like get stuck. See? And so if you go all the way to the left, easy question, guys. What is the value of y that it never seems to touch? It's 9. It's negative 9. I mean, look at that. It's y equals negative 8.999999999. It's a lot of no's, you know? So, y can never equal negative 9 just by graphing it and looking at it. Yes, that is good enough. Seriously. So, for part F, the equation of the horizontal asymptote, very important, is going to be y equals negative 9. So the way you can think about it is that the equation of the horizontal asymptote is y equals negative 9. And in your function g of x, y can never equal 9. And so the equation of the horizontal asymptote is exactly y equals 9. See? Notice that is important. One thing is the equation, one thing is what g of x can never be. So g of x can never have y equals negative 9. There's a negative missing there. So g of x can never equal negative 9 for y. And so your equation of that horizontal asymptote is exactly at y equals negative 9. See? That is a small sort of thing you have to get in your brain because it is part of how you're supposed to answer. For example, here they tell you for the horizontal asymptote, you write y equals negative 9. See, that is the equation. That you actually get negative points if you put g of x equals negative 9. See? Gx can never equal negative 9. Technically, you can write it like this. And then this implies that your equation is at y equals negative 9. See? That is the more clear sort of explanation. All right, whatever. So, that is g. And then the third function, h. Oh, wait, fuck. That is f, that is not g. So for g, they tell us to find the solution of f of x equals g of x when x is greater than 0. And so, go piece by piece. Right now, we need to find the solution of f of x equals g of x. So let's go ahead and write that over here. F of x equals g of x. Now, what is f of x? What is g of x? We know that f of x from this exercise up top is this. So f of x is going to be 3x minus 1 plus 4x to the power of negative 2. We know that g of x for part E is going to be this guy here. See? So g of x is 4 times 1.5 to the power of x minus 9. And so here we need to find find the solution when x is greater than 0. See? So some of you are probably looking at this thinking, damn, how the hell do I figure this out? See? And so what I suggest, you guys, the main tool, and I have a video on this but I'm going to do it detailed here anyways, is the calc intersect trick. Actually, you know, put it up here. So the calc intersect trick. What the calc intersect trick does is that it helps you find the intersect or where it equals one equation to another. So if you call all of this y1, if you call all of this y2, and then you do calc intersect, you're going to find exactly the value of x that makes these things equal each other, literally. And so, but let's understand a little bit why, okay? So you go to y equals, well, actually, we're going to switch this around just because it's already ready. So this is going to be y1, this is going to be y2, okay? So this is y1, y2 is going to be this, so 3x minus 1 plus 4x to the power of negative 2. If you go ahead and graph this, double check that you plugged in right. If you go ahead and graph this, see? Okay, so the solution of x, let me zoom in a little bit more, or let me do zoom fit to see if I can find the intersects. All right, as you can see, sometimes zoom fit doesn't help as much as we'd like it to. Yep. Let me change the window a little bit. So y min, let's make this, I don't know. -10. Y max is fucking huge for some reason. Nice. This will look a little better probably. Alright, so there's my equation or function with the asymptote. And there is my other one. And so, just to be mega clear now, let me make an even smaller x min. Yeah, so this is what we're dealing with. We're going to work with this graph here. And so basically, we need to find the intersection of these 2 points. We need to find the value of x that solve this. And so right now, where are my x-intercepts? I have 2. I have one down here, and I have one up there. And so what we can do is we can go second calc for the calc intersect. And here it asks for the first curve. Usually picks it out pretty easily. So this is my first curve. And then the second curve is over there. See? Then we have guess. So guess helps you pick your intersect. Now they are asking for which one? They're asking for when x is greater than 0. And so that is why some people maybe they go to guess over on the other side and they do find an intersect. They're not wrong. It is an intersect, but it's the wrong intersect. Actually, in the answer key, it says like you get 1 point for process and 1, but no point for the right answer. See? Yes, you did the calc intersect correctly, but this intersects here at -2.39 is the wrong one. Literally, it's the wrong one. All right? And so go ahead, do calc intersect. Make sure you're on the positive side. Okay? Make sure you're on the positive side. Guess over there. Here is your intersect that you're looking for. It is at 4, comma, blah, 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 11.25. See? So this is the point of my solution, and the solution itself is the value of x. Okay, so the value of x is going to be x equals 4. That is for part G. All right, and h, we're almost done. We need to consider a third function, h, where h is the sum of both functions, f of x and g of x. That tells us that point C, which is -1, q, lies on the graph of g of x. We need to state whether C also lies on the graph of h of x. So, piece by piece, what is point C? And so point C, they tell us that it's an x of -1 and the y of q. Okay, y of q doesn't really help, so let's find out what q is. And so this point lies on the graph of g of x. So what was g of x? G of x, we have it right here, see? So let's go ahead and plug in -1 for g of x and see what I get. And so if I go ahead and plug in -1 for g of x, I'm going to have 4 times 1.5 to the power of -1 minus 9. All right, so technically, from what I just found here, I have that the point C, okay, point C is -1, comma, -6.33, never ending, see? And so now we need to see if this point also lies on the graph of h of x. Now what is h of x? H of x is f of x plus g of x. So h of x is f of x plus g of x, which is the same as me saying that h of x is, well, f of x, ¿cierto? So it's going to be 3x minus 1 plus 4x to the power of -2. So that is this here. Plus g of x, which is 4 times 1.5 to the power of x minus 9. That is g of x. And so this whole thing is h of x. Now, what we can do from here, okay, is see if point C exists, if it makes sense. If it makes sense, plugging in point C should give me a value in h of x that makes sense, okay? In other words, I can go ahead and plug in, so point C was what value for x? It was -1. So if I go ahead and plug in -1 for h, I'm going to have -1 here, right? So it's going to be 3 times -1 minus 1, see? Plus 4 to the power of -1 to the power of -2. I mean, 4 times -1 to the power of -2 plus 4 times 1.5 to the power of negative 1 minus 9. And so if all of this equals negative 6.33, then point C exists. If it doesn't equal negative 6.33, then h of negative 1 gives me a different point. See? Let's see what happens. Let's figure it out. So 3 times negative 1 minus 1 plus 4 to the power, times negative 1. I keep messing that up. To the power of negative 2 plus 4 times 1.5 to the power of negative 1. That is not a negative 1. Now it's a negative 1 minus 9. Now I just plugged in a bunch of shit, so let me double check. We all make mistakes, so 3 times negative 1 minus 1 plus 4 times negative 1, blah, 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 blah. No one cares, blah, blah, blah. Okay, cool. Aha! So when h is negative 1, this does equal negative 6.33, and that is a way in which we can say that C also lies on the graph of h of x. What is the justification of my answer? The justification of my answer is that h to the power of negative 1 equals negative 6.33. And that, part of my analysis, g to the power of negative 1, point C, ¿cierto? Gives you negative 6.33, which is the same as saying that q equals negative 6.33. All right, so ladies and gentlemen, that is how we solve h, and that is actually all of number 2. I extended myself a little bit in some parts, but you know what? I think it was pretty good review, and I'm sure at least one of you out there appreciated it, and whoever that is, this one's for you. So, ladies and gentlemen, I hope it helped. I hope you feel better. That is for number 2.